class, hi other students at our school, parents, teachers, students from everywhere. I started these videos to help my students review things that they've learned throughout this year during the quarantine, realized I could use it forever for homework help, and then I started thinking anybody could probably learn from these. So please like, subscribe, and share. Let's get as many students learning as possible while we're all at home. If you have a question you want me to cover, I'm going to be starting with 5th grade stuff because that's what grade I teach, but just send me an email, connollymathathome@gmail.com. This is an O, so just pay attention to that, and I can help with any grade level if you want. Just let me know what you need, and I'll do my best to help you out at home. So today we're going to be talking about making equivalent fractions. Hold on, the eraser fell. We're going to be talking about making equivalent fractions. And this comes up in previous grades, but we need it in 5th grade in order to add and subtract fractions with unlike denominators and of course with mixed numbers. So this video should be a good review for everybody. So let's get started. A good number to think about when we're talking about equivalent fractions is 1/2. And when I'm thinking about equivalent, I'm thinking about equal. I want something that is the same amount as 1/2. Okay, so we always want to think about the visual representation with fractions. Okay, so I'm going to represent 1/2 here. And I want to think about how can I find an equal amount to this. So I want you to think about how can I make this same representation show fourths. So think for a second. I want to show fourths. So one way to do it is to cut your pieces in half this way. So I used to have 1/2 shaded in, so I used to have 1 out of 2 equal pieces, but now I see 4 pieces. 1, 2, 3, 4. So I've made 4 equal pieces. And I want to think about how many are shaded in out of those 4. 1, 2. So I want you to notice that nothing changed about the shading. The same amount is shaded in. That's how we know that this is an equivalent fraction. That's one way that we know. And one thing that you might be noticing is that the number of pieces increased. Okay, so we had 2 pieces at first. Now we have 4 pieces. And you notice the pieces are a lot smaller than they were with halves? We made smaller pieces. Since we made the size of the pieces smaller, we need more of them. So that's why our numerator is getting greater as our denominator is getting greater. When the denominator gets greater, the pieces get smaller, so we need more of those pieces. Okay, what else is going on and what we want you to start learning, because this is the first part, we want the visual representation. What is the relationship between the 1/2 and the 2/4? Okay, I'm going to show you. What happened is we doubled the number of pieces. So there were 2 pieces when we started with halves, but when I cut it in half, I made 4 pieces. So my denominator got multiplied by 4. So what happened to the numerator? Or sorry, my denominator got multiplied by 2 and I ended up with 4. So what happened to the numerator? Well, I also needed double the pieces if I was doubling the number of pieces in the whole thing. Okay, so what we see here is the numerator and the denominator got multiplied by the same number, and we ended up with 2/4 being equivalent to 1/2. Again, we multiplied the numerator and denominator by the same exact number, and we ended up with 2/4. You see it in the representation, the pieces got smaller. It used to be 1/2, they got smaller, and since those pieces got smaller, we needed more of the pieces to make the same amount. Okay, so we're going to try it with another one. Let's see what happens. All right, so this time we're going to start with 2/3. I'm going to make my representation because that's always a great way to understand things with fractions. Make a representation and ask yourself what is going on. All right, so I have 2/3 represented, and I want to think about ninths. So I want you to think for a second if there's a way that we could change this representation so it showed 9 equal pieces, ninths. So once you've had a second to think, you can pause me if any time if you need to think for a minute. To make ninths, I'm going to draw 2 lines there, okay? So now let me double check. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 pieces now. And you might be starting to think, I hope you're starting to think, those pieces got a lot smaller. They used to be, this third here was this big, and now it takes 3 times the pieces to make the same amount. Here and here. So since my pieces got smaller, I need more of them to make the same amount as when I had bigger pieces. So let's count how many pieces we have now. 1, 2, shaded in. 1, 2, 3, 4, 5, 6. We have 6 pieces out of 9 shaded in. So what is the relationship between 2/3 and 6/9? Well, what happened was I made the pieces smaller, as you can see. I made triple the amount of pieces. I used to have 3 pieces, now I have 9. So I multiplied the denominator by 3. That's how we got 9 as a denominator here. And so what happens to the numerator? Well, since I had tripled the number of pieces total, I needed 3 times more to make the same amount because the pieces got so much smaller. So we see the same thing happening. If you multiply the numerator and the denominator by the same number, 2/3 times 3/3, you're going to get an equivalent fraction, 6/9. Again, what we did was we multiplied the numerator and the denominator by the same number. You should see it here, 3/3. And we ended up with 6/9. So those are equivalent fractions. You can see it in the representation as well. We didn't change how much we shaded. I just made more pieces. So I needed more, since the pieces got smaller, I needed more pieces to make the same amount. And that's how we're thinking about equivalent fractions. All right, so let's look at another way to make equivalent fractions. So just as to sum that up, multiply the numerator and denominator by the same number. When your pieces get smaller, you need more of them to make the same amount. That's what's going on here. All right, so something else happens when we have equivalent fractions in play, and that is what I'm going to represent next. Okay, so let's say we're starting with 4/6. So I have 6 equal pieces. I'm going to shade in 4 of them. And I have 4/6. What if I wanted to show thirds here? How many thirds would be equivalent to 4/6? So I want you to think, if you see thirds in the representation, if you need to pause for a second to see where you could see thirds, go ahead. I'm going to continue. So if I wanted to change this to thirds, I would get rid of this line here. So do you see my thirds now? I'm going to highlight them in purple. 1/3, 2/3, 3/3. You notice the amount shaded in did not change. So what is equivalent to 4/6? 1, 2 out of 3. It's equivalent to 2/3. And you might be saying, well, you didn't multiply something by 4 to get to 2. And you're right, I didn't. What happened this time is I made my pieces larger. Okay, you saw they used to be sixths. I made them into thirds. I made them larger. So then you need less pieces, okay, to make the same amount as 4/6. So what happened from 4/6 to 2/3? Well, I used to have 6 pieces. But when I divide 6 divided by 2, I ended up with 3 pieces. What happened to the 4? I also divided that by 2 because I needed less pieces because the pieces got larger. So in this situation, instead of multiplying the numerator and denominator by the same number, I divided the numerator and denominator by the same number. So 4 divided by 2 is 2, 6 divided by 2 is 3, and so we see 4/6 is the same as, that's what the equal sign means, 2/3. Okay, again, I divided the numerator and the denominator by the same number and ended up with 2/3. I had sixths, which were smaller pieces, and I made an equivalent fraction with thirds, which are larger pieces. When I had the smaller pieces, I needed more of them, but since my pieces got bigger, then I needed less of them, and that's why you see the division going on here. Okay, we're going to do one more example, then you're off to work on your own. Parents at home, there is a website called Common Core Sheets. So if your kids are watching this video and you want them to practice, you can either make up your own questions or search the standards on there. That website's really helpful just for repeated practice. All right, so one last one. Let's do 5/15. So let me represent that here. And I'm going to shade in 5/15. 1, 2, 3, 4, 5. All right, the last thing I want you to understand is when you are dividing the numerator and denominator by the same number, you have to think about what factor do both of these numbers have in common? What can you divide both of them by? Okay, and I'll give you an example of a time when you can't divide by anything. So if you have 4/5, you know you can't divide 4 and 5 by the same number. So in this situation, you wouldn't be able to use this strategy, okay? You have to think, does this strategy work? So back to what we were doing. 5/15. What number goes into 5 and goes into 15? I'm sure you noticed that 5 divided by 5 and 15 divided by 5 are things that we can do. Okay, so I thought about what do these numbers have in common, what factor do they have in common. They're both divisible by 5, so that's where I'm going to go. So if I divide 15 by 5, I'm going to end up with 3 equal parts. So let me get rid of those extra parts. And I want you to see that we end up with thirds. Okay, so I erase those extra 5 lines. I divided my total number of parts by 5. I used to have 15, I divided by 5, and now I only have 3 equal parts. Okay? And you'll notice that since they're so much bigger, I don't need 5 pieces anymore, and there aren't even 5 pieces in this hole anymore. Okay? So what we think about is we need less pieces because our total number of pieces got larger to make the same amount. So, as you know, whatever you do to the numerator, you must also do to the denominator. Whatever you do to the denominator, you must also do to the numerator. So, we're also going to divide this by 5. And 5 divided by 5 is 1. You end up with 1, do you see it? Third. Nothing changed about the amount that's shaded in. What changed was the size of the pieces. They got larger. And since I made bigger pieces, I didn't need as many of them, so the numerator also got divided by 5. So, just to recap, you can multiply the numerator and denominator by the same number to make an equivalent fraction, or you can ask yourself, can I divide the numerator and denominator by the same number? Do they have a factor in common? So if they do, then you can also make an equivalent fraction this way. Okay? So try your work. If you have any questions, text me or call me if you're in my class. If you want to get in touch with me, conleymathathome@gmail.com. And thank you for joining us for equivalent fractions. Bye.